So today we'll be moving on to a new chapter, relations and functions. So yeah, today we'll be today we'll be having the part 1. There'll be an introduction to this chapter. So the first question that you always ask, what is this? What is this relations and functions? Okay, so thinking about relations, few things come to our mind. The relationship with our parents, the relationship with our grandparents, um, but I know that these are all relations, but this is not exactly what we are planning to do here. To find the relationship, to find the quality of relationships with other people, I don't think so we can apply max. But here in this chapter, in this topic, what we'll be doing here is to find relationships between different sets of what it could be, if sets could be anything, sets of pencils, sets of numbers, sets of alphabet, sets of people, so sets of chairs, sets of table, it can be anything, any set, a relationship between different sets, more specifically two sets, I would say, because here in this chapter we'll be only dealing with two. So a relation, what we are considering is a relationship between different sets. I would say two sets will be more better. Let me give an example of two sets here. A natural numbers come starting from 1 ending at 9, and then I'm going to put some other numbers. What I'm going to square each of these number. So each of this natural number, I'm going to square them and I'm going to write it here. That'll be 1, 4, 9, 16, 25, 6, 36, 7, 49, 8, 64, 9, 81. Yes, done. So here I have set of natural numbers from 1 to 9, and here I have a set of numbers which are the squares of these numbers. Now it is just two sets. How to show that there is a relation? There is a relationship here, right? A relationship of squaring. Squaring is a relationship, or square is a relationship here. Now, how to show that there is a relationship? For that I use this symbol, arrows. So okay, I have already drawn 3 arrows here. You can draw more arrows for 2 and 3 and all. To decrease my work, I have to do that. When you have time, since you have time, you can draw more. Okay, so by drawing these arrows, I'm showing that there's a relationship between two sets. Okay, let that be it. Let us move on. Now think about it as a machine. You put some inputs, you put some inputs into the machine, you put some things into the machine, and then you get some other things out. For example, if you put a square into this machine, you're getting a circle out of this machine. It looks weird, it sounds weird, but it is, of course, this chapter will feel kind of weird because it is mostly theory, but these are kind of important theories, so try to go along with it. So if I give some inputs, if I give some things into the machine, I'm going to get some new things. For example, if I put the grains of if I put wheat grains into the machine, into the mill, or if I put rice, or if I put chilies into the mill and I give it to the mill and tell them to grind it, they put it into a grinder and we get it as powder, right? So like that, you think of it as a machine. You put something into the machine and you get something out. So that out is called output. What we get out is called output. So we know the relation between these inputs and these outputs is what? The machine. For example, if it is a machine to powder things, then whatever you put it into the input, we get it as powder, as the output. So depending on the machine, the relationship can change. So a machine is the relation here, and we put some things which is called input, then we have a set of things that we get, that is called output. Now this is a relation. This is the relationship that we'll be looking on in this chapter. It will be a relationship between the inputs and the outputs. So now the chapter name was relations and functions. So what are functions? Guys, let me tell you something now itself. Functions are not exactly a different topic, but functions are also relations. Yes, functions. So basically what we are studying in this chapter is only relations. Functions is relations, but there's the but is highlighted here. It is a special type of relation. What makes it special? Yes, there are some terms and conditions. That is, for one input there should only be one output. For one input, one output. This is pretty important in the functions. So how to say a function? See, everything is a relation, but not everything is a function. So how to say something is a function or not? You need to check that for one input you should only get one output. That is a condition. Now let us look at an example and then we'll be able to understand. This is our xy graph. Now I'm putting a equation here, y is equal to x. Now how will this be? This will be for example, if this is 1, this will be 1, and if this is 2, y is equal to x, this will be 2 here, and if this is 3, here also it will be 3, right? So let us check at the graph. Yes, this will be a straight line here. Now if I take this point at 2, here also I will be getting 2. If I take this value at 3, here if I check this coordinate, that is 3, and if the y coordinate is also 3. So I see that when I give 3 as the input, I get 3 as the output. When I give 2 as the input, I get 2 as the output. So for one input I see that there is only one output here. For example, if I give 3, I don't get 2 as the output. Because if I get 2 as the output, then I have 3 and 2 as the outputs. So basically, if I give 1 here, the answer is 1. So for each input, I'm getting different outputs, but there is only one output. For one input I see only one output here. This is how functions are. Now you might be thinking, sir, in every situation it's like that only, right? One input means only one output. Nope. For example, think about this relation, square root. If 4 is the input, and if I ask you to find the square root, what will be the answer? The answer will be 2, yes, and minus 2, because 2 square is 4, minus 2 square is also 4. So I see that in the root x relation, that means when I'm applying the relation of square root or relationship of square root, what happens is I'm getting an output 2, and with the same input I'm getting another output minus 2. You get it? So for one input I'm having 2 outputs here. Therefore root x or square root is not a function, but it is of course a relation. It is a relation. Of course it's a relation, there is no doubt in that, but it is not a function. I hope this much is understood. Okay, now let us look on to more graphs. So here, what we will do is we will check. We will look at another test to check, whether any equation is a function or not. But instead of looking from the side of equation, we will look from their graphs. That means every equation has a graph. For example, you just saw that y is equal to x. It has a graph of a straight line. So likewise, every equation has a graph. Y is equal to x square. It is a y is equal to x square, it is a parabola. Okay, I'll show that anyways in the coming, I'll show that very soon. So we will look from the side of the graphs and we'll see whether it is possible to say whether they are functions or not, or are they just relations. So let us look at one. So first let us look at a parabola. I don't know whether, I'm not sure whether you know what a parabola is. Okay, but a parabola, okay, first let me draw my x and y axis, my x axis, my y axis. Okay, that doesn't look like a y. Yeah, better. So then let me draw my parabola. This will be my, I'll use a different color. Yeah, this is my parabola. And the equation of a parabola is y is equal to x square. This is the equation of this parabola. There are types of parabola which I'll show you later, but equation of this parabola is, or this shape, what you see is y is equal to x square. Okay, now without looking at its equation, by just looking at the graph, how can we say whether a relation is a function or not? For that, now we already know that this is a relation. There is an output, there is an input, so it is a relation, no doubt about it. The question is whether this relation is a function or not. Okay, so let's see. There is a test called a vertical line test. That is vertical line, vertical line test. So using this test, as its name says, it's a vertical line. So using this test, a vertical line test, we are going to see whether our graph is the graph of a function or not. Okay, so let me put my vertical line. Yes, this is my scale here. As you all know, scale is always a vertical line. So when I pass this vertical line through this parabola, I should, what I should check is whether this line crosses one point or more than one point. That means if you see, this line passes through only one point of the parabola at a time. See, only at a time it passes through only one point. See, only one point of the parabola at a time. So it never ever crosses at 2 points, only 1 point. Now only in this case, that means only when it crosses 1 point in a graph, only when the vertical point passes through only 1 point of the graph, it is called, this graph will be the graph of a function. That is, this relation is actually a function. Y is equal to x square is a function. This is the test. Let us go to another. Let us look at our straight line which we looked till now. So in our straight line, this was our function. This was our graph. Let me take a different color. Yeah, straight line. Yeah, it's almost straight, right? Okay, so let us check whether this straight line is a function or not. What is the equation of a straight line? Y is equal to x. Okay, when y is equal to x is the equation of this straight line, the specific straight line, because the actual equation for straight line is, y is equal to mx plus c, where m is the slope and c, and mx plus c, where m is the slope and c is a y-intercept. Now I don't know whether you know all that, but this is the general equation of a straight line. We won't be going, we don't, for now, we will only take, this is the case of when m is 1 and c is 0, when m is equal to 1 and c is equal to 0, this is what happens. So this is a special case. Okay, y is equal to x. Now Let's come back to a straight line. So let us put our vertical line again. Now when I pass my vertical line through many points of the line, when I pass my vertical line through the straight line graph, I see that again it passes through only one point. See, it never passes through more than one point, only passes through one point of the graph. Therefore straight line equation is also a function. That means y is equal to x is also a function. Nice. Now you remember the parabola that we checked? Let us do that parabola thing again. That is, this is our parabola. Now let us do this parabola thing again. That means I am going to rotate this graph. Now what happens when I rotate this graph? This part actually becomes x-axis. Okay, let me change my color. This part becomes x-axis and this part becomes y-axis, right? So now if I pass my, so what is the equation of this one? Is it the same equation? No, the equation is equation is x is equal to y square. Before the equation was y is equal to x square, but that was this parabola. When the parabola turns the other way, or when the parabola is rotated to the right or in the clockwise direction, then the equation becomes like this: x is equal to y square. So now is this graph the graph of a function or not? Let us check. Let's put our vertical line, and if I pass my vertical line like this through the graph, I see that there is an issue here. It passes through one point here and passes through another point here also. That is one point here and one point here. Again, if I move one point here, one point, so I see that if it crosses 2 points at any point, then it is not a function. So I don't have to keep checking. So let me check at only one point. Here I see that it passes through 2 points. This is enough to say that x is equal to y square is not a function, but it is a relation. Of course it's a relation, but it is not a function. We can never say it is a function because it passes through 2 points. So that is so powerful. Then let us take another example. Let us come back now. Okay, now so let me show you another graph. This time the graph is going to be a circle. This time the graph is going to be a circle. Okay, wait, why circle is not? Oh yeah. So the equation of this graph is y is equal, okay, I will tell you a little more about this graph. So in this case, in the case of this graph, the equation is x square plus y square is equal to 1. Why 1? Because the radius of that circle which I drew is 1. That is why. Okay, so if I am putting it, I can always write this will be y square is equal to 1 minus x square, and y is equal to root of 1 minus x square. Right, so this is my equation, and now I will check whether this equation is a function or not. So let me come back to the graph. Let me put my vertical line again. So when I pass my vertical line through this, I see that again there is an issue. That means this vertical line passes through, this vertical line passes through 2 points now. 2 points. At this point there's only 1 point, but wherever you go other than this point, and here also it only crosses 1 point, but everywhere else it crosses 2 points. So because the function passes through 2 points, it is not because the equation passes through 2 points, it is not a function, it is only a relation. So the function test, so the circle has failed the function test. So this is how we check whether, when we have a graph, this is how we check whether a relation is a function or not. Now if you don't have a graph, we can draw a graph and then check, because it's always easy to draw a graph. How to see, if you want to draw a graph, it is not that difficult. How to just put somewhere, make a table, just write x, y, make a table, put one value for x, make 1, and see by the equation what you get value for y, then 2 what you get value for y. So then substitute that points on the graph, and then you will get a graph. That will be the graph of the function. Okay, so these are some methods. One method to check is manually you can put some values and see whether for the same input many outputs are coming or not, or we can check and see by the graph test or the vertical line test. We can see after drawing a graph whether a relation is a function or not. So this is how we differentiate between a function and a normal relation. So yeah, I think that will be it for today. I hope you guys have understood what this topic. Yeah, so if there's any doubt, let me know. Okay guys, thank you for listening. Bye bye.